Hi everyone, welcome back to my channel. In this video, let us see type 2 numericals of GSLF method. The question given is consider 3-bus system. Bus 1 is a slack bus. The line and bus data is given here, and they gave the circuit. We need to calculate power flow solution, that is voltages and power flow, line losses, and so on. This is a figure, and these they gave in the impedance form. We need to convert into admittance. Okay, now this admittance means example Z12, right? Z12 is equal to 0.05 ohms. To convert these into admittance, 1 divided by Z12, that is 1 divided by 0.03 plus 0.05. This is equal to 8.835 minus J 14.706. Similarly for Y13, okay, Y13 that is 1 divided by Z13. Z13 is this 1 divided by 0.025 plus 0.04 J. This is equal to 11.236 minus 17.98 J. And Y23, this left out with Y23 is equal to 1 divided by Z23. This is equal to 1 divided by this value 0.02 plus 0.01 J. This is equal to 40 minus 20 J. Now we have converted these impedances into the given impedances into the admittance. Now our first step is Y-bus calculations. So since Y-bus calculation is very basic step, and I am calculating it directly, we need Y11 element, right, startingly. So from one bus we have to see 122 plus 123, Y12 plus Y13. We need to add these two values. That is, we'll get 8.8235 minus of 14.706 I plus 11.236 minus 17.98 I. First keep this in the calci mode. To keep calci mode, just on and mode click and complex will get is equal to, we got the 20.059 minus of 32.68 6J. Similarly, now this element is Y12, right? First row, second column, Y12. Y12 means this. Y12 is this value minus of this. To understand these minus and pluses, you can go through my first type 1 numerical. I explained clearly. J14706. This is plus. Minus of this element. This is small y elements, all are. And we need now Y13. Okay. First row, third column. Y13 we have minus of this value 11.236 plus 17.98 J. Similarly, we get Y12, right? That is equal to Y21 element. How to rate these 5-bus system? You can watch my previous video. The video link is in description. Now we got this Y-bus. Our very first step is over, and we'll go to the second step. Second step is check the system in PU. Check whether the given values in PU. At bus 1, that is slack bus, right? Slack bus. But when V1 0 is equal to 1.06, it is in PU. Okay. And at bus 2, what is bus 2? Bus 2 is load bus, right? No generator connection. Therefore, load bus. Load bus is PQ. Load bus means PQ bus. Okay. Now first generator section part. See here, we are at bus 2, right? Bus 2, we have generator part 0 0, because there is no generator connection, therefore they don't give anything. 0 0, and load they have give 300 and 150. These are in MVAR. This is actual, we need to convert into PU, right? And take base MVA as 100. Now this is PG2 and QG2 is equal to 0 0, because no generation at second bus. And then we need to check for load. PD2 QD2 is equal to PD2 they gave, right, at second bus. PD2, that is 300, and QD is 150. Therefore 300 divided by 100 MVA, this is base 100 MVA, we have to convert into PU. This is 3 PU. Similarly, this is 150 divided by 100, this is 1.5 PU. Now we're done with this at bus 2. Now at bus 3. At bus 3 they gave only PG2 value. See here, PG2 value, okay, sorry, PG3, okay, we are a third bus, PG3 they gave, and no QG value and PD value, all are 0, okay. This is at 3 bus is generator bus, that is PV bus. First we will check for generator has PG3 is equal to, the value given is 200, to convert into PU divided by 100, 2 PU, and QG3 is equal to, they not gave, and they gave the constant limits, okay. Keep this, remember, QG3 is 0.1 to 0.5, limits is given, still it's question mark what is the value. Now check for the load. PD3 QD3 both are 0, because we have only generator right here, we have only generator, no load values, therefore 0 0. Now a second step is over. Now the third step is for P1 Q1, P2 Q2, P3 Q3, we need to calculate these all parameters. Since P1 is equal to 0, Q1 is equal to 0, because of slack bus, okay, because of slack bus, and P2 is equal to PG2 minus PD2 formula, and Q2 also QG2 minus QD2 is equal to PG3, similarly PD3 QG3 minus QD3. By substituting these values, since we have calculated PG2, QG2 and so on, we'll get like this, that is P2 is minus 3 and Q2 is minus 1.5 and P3 is 2 and Q3 is, we have limits, okay. For generator they gave limits, we need to calculate these value. Our next step is calculating voltages. Since V1 of 0 they gave, that is 1.06 volts, and V2 0 they don't give, we assume that as flat start 1 angle 0, this is flat start, and V3 of 0 they gave that 1.04. Now we need to calculate V1 of 1, V2 of 2, V3 of 3. Therefore V1 of 1 is equal to V1 of 0, this is equal to 1.06. Now V2 of 2, this is formula, since we are at second bus, right, divided by Y22 in the bracket of P2, since only we are at bus 2 only, okay, P2 value minus JQ2 divided by v2 star 0, sorry, v2 of 0 complex, minus, since we are at bus 2 we wrote v2 of 0, still we are at bus 2 only, we need to write the elements y elements of bus 2. Initially bus 2 y21 y22 we already wrote, therefore next y23 we remaining.
If any
We
doubts
don't have
or queries
y24
related
and
to
we don't
these
have y4
questions,
buses,
you can join my
therefore
Telegram
stop here.
group,
And
link in the
we all
description.
now write
Comment
v1
me for
of
any other queries.
0.
Thank you
v2
for
of
watching.
0 is already there here, therefore you write v3 of 0, close the bracket. Substitute all the values. y22 is we will get from the y bus, this is 48.8235 minus 34.7j. In the bracket of p2 we have calculated, that is minus 3 plus j 1.5 divided by 1 angle 0, that is complex, minus y21 is here, y21 this value, minus of 8.8235 plus j into 14.706 into v1 of 0, they gave that 1.06 minus of y23 is this minus 40 plus 20j multiplied by v3 of 0 is 1.04. After calculating this all in the calculator, you will get 0.9899 minus of 0.0109j, or in a polar form 0.98996 angle of 0.631. Keep the answer in both the polar and rectangle form. Now we need to find v3 of 3, that is 1 by, we are at bus 3, right, therefore y33 bracket of bus 3 only, p3 minus jq3 divided by bus 3 only, v3 of 0 whole complex, minus, and now we are at bus 3, right, therefore write the bus 3 elements, y31 minus of y32, y33 already there. Now start with v1 of 0 and v2 of 0, v3 of 0 already wrote, close the bracket. Since we have calculated that v2 of 1, right, since we already calculated v2 of 1, therefore we need to use the latest value, only we need to change this, okay. If you change this also, since we have already calculated v1 of 1, we can change this, but there is no difference between these two, right, only 1.06 only will get. Therefore substituting these all values, since, and we don't have q3 value, because q3 we have limits, right, we need to find q3, don't take further step, therefore keep this as equation 1, and we need to calculate now q3. For q3 it is have a formula, that is minus of imaginary q3 1, because this is q3 0 type, small, like keep that, because this is limits. Now we need to find q3 1. q3 1 formula is minus imaginary bracket, and we are at bus 3, right, bus 3, that is v3 of 0 whole complex, open brace, and we need to write bus 3 only, we need to write bus 3 elements, y31 and plus y32, remember this plus, y32 plus y33, v1 v2 v3 all voltages, and 0 0 0. Now we need to use the latest voltages, since I am writing 1, this also 1, we don't have y3 of 0, sorry, okay, we don't have latest value of y3 of 0, we need to find, right, we need to find out that y3 of latest value is equal to, substitute all those values, v3 of 0 we have we already have that 1.0, complex means is nothing but example a plus jb is nothing, complex is nothing but imaginary part becomes minus, that's it, plus into minus, minus into plus, plus becomes minus, minus becomes plus, only this. For this there is no difference, 1.04 plus 0 means minus 0 means no difference, therefore we will take 1.04. in the bracket y31 element, y31 here it is. We have to substitute all those values. After substituting all those values, after calculating these inner values, first we need to calculate these all values, multiplications and additions in this bracket, and we need to multiply whole answer with this. We'll get total answer, that is 2.0722 minus of j 0.2147. We'll get like this. Since we have to take minus of imaginary part, say minus of imaginary, therefore only take magnitude value, that is 0.276. If this is a plus here, we need to change the sign. Okay, q3 of 1 becomes now 0.2. Substitute these value in here, and remember that okay, we need to check for these value, we need to check the limits. Since see here 0.1 to 0.5 is the limit, and this value is in within limits, that is 0.1 to 0.5. Since this value is selected, if note, if out of limits, if these q value is out of limits, say like 0.09 or 0.6, in that case if 0.09 will get, that is less than 0.1, we need to take q31 as 0.1 only. If we get that is 0.6 above 0.5, above the limit specified, okay, we need to take 0.6 nearest limit is 0.5, right? We need to take q31 as 0.5. Keep this, remember, because we got a 0.2, this is in within limits. Okay, this value is selected now. Now this equation 1 can be written as, equation 1 implies that is v3 of 1. We need to substitute all those values, and we got p3 minus jq3 is there, right? Here where it is p3 minus jq3, we got q3 just now we have calculated, and substitute all those values. I have substituted all those values. Now this is q3, right? Okay, q3. Now after calculating this all, v31 becomes 10391 minus j 0.0006938, or we'll get 0.39 angle of 0.03823. After getting v3 of 1, since we have involved for v3, we have calculated v3 and they gave the limits. Okay, they gave the limits. For generator, remember that after we will getting, if there is a generator, we will get v31, and by calculating this q3 extra step, we need to take this angle value, that is v3 of 1. Finally v3 of 1 is equal to, we need to keep the angle as it is, that is 0.3823, and we need to change don't take these magnitude value, we need to take the magnitude value of v3 of 0. Remember that is 1.04 we had to take. This is the final voltage, and then therefore write all the latest voltage values. v1 of 0 we calculated that 1.06 angle of 0, and v2 of 2 v2 of 1 we have calculated that 0.98996 angle of minus 0.631, and v3 of 1 that we have calculated this 1.4 minus of 0.3823. We have done with the voltages, we have calculated with the voltages, and the next step step 5. In the step 5 we need to calculate In the step 5 we need to calculate that bus powers. That is, see here, only a generator can supply the power, right? Load will take the power. Therefore, for the generators only we need to calculate. That is S1 we have to calculate bus power S1, bus power S3. That's all. We don't have power at load side. Therefore, S1 we need to calculate. For that formula, for these formulas I done in the previous video lecture, starting at the numericals of GSLF method. I explained these formulas. Please refer that. S1 is equal to P1 minus JQ1, P1 plus JQ1, and P1 and Q1 of slack bus is 0. Therefore, we cannot use this formula. This S1 also equals to V1 into I1 conjugate. Okay, this is the formula, and V1 we can write V1 similarly, and I1C is this. I1 current flow is V1 minus V2 voltages. Okay, V1 minus V2. This I1 splits into, we need to take I1 value at I12 flow and I13 flow. Both we have to add. I12 flow plus I13 flow whole complex is equal to I12 is here only. You remember the suffixes V12 we have, right? Therefore, V1 minus V2 suffix whole into Y12 value. And do remember this is small y12. Small y12 means we need to take these elemental data, not Y bus element. For only powers, for only power calculations, after this voltages what we calculate, we need to take these small y values. Please do remember, for all these values we will take capital Y values. Small y12 plus y13 is this suffix is V1 and V3, V1 minus V3 and y13 suffix. Whole complex. Substituting these latest values only we have to take. For these further uses we have to take these latest values only. Substituting these all values, V1 is 1.06, so on. After calculating this 1.06 we will get 1. After calculating these all value we will get like this, and this is a complex here. Don't forget this. And we need to change the sign of these value. Imaginary part becomes minus. That is removal of complex. After calculating this, we will get final answer as 1.093 minus 1.3621. Sorry, we will get minus this. This is plus. Now we need to find S3, that is P3 plus JQ3. We have P3 and Q3 values we have directly, therefore substitute directly. And now we need to in the step 6 we need to find line flows, that is power flow, line power flow. Okay, that is line power flow is nothing but S12. This is second bus, right? S12 and S21. Similarly, S13 and S31, S32 and 23. Okay, this is bit lengthier but very easy to calculate. First, initially we will find S12. For S12 we have formula, right? V1, because S12 means from first bus we have referring, right? Therefore V1 into I12 flow, that is complex according to the formula, where V1 we have to use these latest values only. Remember that V1, and already I have told that V1 minus suffixes V1 minus V2 into Y12, small y12, not capital Y12, complex. Substituting all the values, V1 V2 voltages and Y bus. This Y is from this, okay, not from Y bus. After substituting all those values, you get 1.06 in the brace of 0.77885 minus 0.93469J whole complex. To remove these complex, we'll write 0.77885 885 plus 0.93469. Only imaginary part we have to change the sign. Okay, S1 is equal to, after calculation we'll get 0.8255 plus 0.9907 J. This is S12 we have calculated. We need to calculate S21. This is equal to, for S21 because first reference is V2, therefore V2 into I21 conjugate. This is equal to, substitute V2 value as this only, 0.98996 angle of 0.631 into I21. Here it is. See, for I21 formula, I21 is equal to minus of I12. This is minus of I12, right? We need to take this value, that is I21 conjugate. I21 conjugate is equal to minus of I12 conjugate. Directly I take the value, minus of 0.7885 minus of 0.93469. After calculating, we'll get 0.7609 minus of 0.93374 J. Now we need to calculate S13. Similarly, we are at bus referring is V1 and I13 complex. V1 into, split this, V1 minus V3, V1 minus V3, Y13 whole complex. Substituting all those values, we'll get 1.06 in the bracket of 0.2372 minus 0.352 J whole complex is equal to 1.06 23712 plus 0.352 J 25135 J 0.3729 J. Similarly for S31 is equal to bus 3, right? We are referring 3 bus, therefore I31 complex. For V3 voltage we have 1.04 angle of 0.0380. And now I31 complex is this. Okay, I31 complex total solution. Okay, I31 is equal to I31 star. This whole value is I31 star. This is I13 star. This is a whole answer. Now we have to write for I31 star is equal to minus of this I13, that is minus 0.23712 minus of 352 J. After calculating, minus of 2468 minus 3659 J. Similarly for S23 V2 I23 star 0.98996 0.631 V2 minus V3 into Y23. After substituting all answer, we will get 1.8 2.8 0.61 J. Similarly for S32 V3 into Y32 I32 complex 1.04 angle of minus 0.38 and V3 minus V2 Y32 whole complex. This I forgot to write whole complex. Answer, you'll get final answer as 2.297 plus 0.616 J. At the last step 6 and the last of step 7, we need to calculate line losses. Line loss is nothing but SL12 is equal to S12 plus S21 is equal to 1.58629 plus 0.06 J. SL13 SL23 SL13 plus S31 SL23 plus S32 is equal to 0.00455 minus 0.7388 J. 0.117 plus 1.226 J. This is the final answer. If you like the video, please do share and subscribe my channel. If any doubts and queries related to these questions, you can join my Telegram group, link in the description, and comment me for any other queries. Thank you for watching.